In the first example, we found that our new sample size was around 120. We actually solved it to be 119. So now that's a pretty dramatic increase in the sample size, and maybe we don't want to use a sample that large. Well, I can get the same margin of error using a smaller sample size, but the trade-off is I'm going to have to use a smaller critical value. I'm going to have to use a smaller z star. In other words, I'm going to have to give up some of my confidence. So let's say instead of 95% confidence, let's lower our level of confidence to 90%. So let's set our margin of error again. Let's say we want an 8% margin of error. So, but let's say this time I am interested in finding the z star, whatever it will be, to give me 90% confidence. Well, let's remember what that means then. I can draw our normal distribution. What we are looking for, here is the mean. So what we are trying to find is the critical value, the z-score, or how many standard deviations above the mean and below the mean we need to go in order to account for the middle 90% of the sampling distribution. Now, in order to calculate this, what I need to do is enter the percentile. So let's look at this sampling distribution. I've accounted for the middle 90%. That means I have cut 10% off of the standard, rather off of the sampling distribution. That's 5% to the bottom, 5% on the top. So this z-score, the percentile to which it corresponds, that includes not just the 90%, but also the 5% that we have cut off from the bottom of the sampling distribution. So really what I have to do is put in the 95th percentile. So when we go to the applet, choose probability, normal distribution. So I don't want to calculate an area under the normal curve. I want to find the value that corresponds to the 95th percentile. So I would use a mean of 0 and a standard deviation of 1. That will use straight z-scores. That will give us what's called the standard normal distribution. So I'm interested in an area of 0.95. This will give me the 95th percentile, 1.645. So here we go, back to our calculation. So I know that 1.645, that's the critical value I want to use in order to set 90% confidence. I want to keep my margin of error of 8%, and we will go ahead and continue to use our best guess for what we think the truth is, that's 73%. So we can use our formula here. We'll set it up. So our new sample size is 0.73 times 1 minus 0.73. So I still want my margin of error of 8%. This time for 90% confidence, I can use a critical value of 1.645. That quantity still gets squared. So let's see what we get. Here we go. So the numerator, 0.73 times 0.27. In the denominator, we have our margin of error again, divided by the 1.645. That quantity gets squared. So we have indeed lowered the sample size. It's still a whole lot larger than the 30 that was actually used when this study was done. So again, we want to round up to establish that margin of error of 8% at the 90% level of confidence. So the sample size to use here, I would choose 84. So there's a trade-off. I can use a smaller sample size and get the same margin of error, but the trade-off is I have to lower my level of confidence. Hope this has been helpful.